Behind every single safety rule, there's usually a story. And a lot of the time, it's a tragic one. Today, we're going to dive into the really critical OSHA regulations for electricity on construction sites. And these aren't just some boring rules on a page. They are life-saving instructions, really, written from some very hard-learned lessons. So let's unpack the rules designed to make sure these kinds of tragedies never happen again. We're going to start where these rules matter the most, right on the job, where just one tiny moment of oversight can have, well, permanent consequences. This first part looks at a real-world scenario to show you exactly what is at stake. This is the kind of question that haunts safety investigators, right? How can something so small, something that probably gets overlooked every single day, lead to the absolute worst possible outcome? Let's take a look at the chain of events. So in this tragic, real-life case, a worker was electrocuted, and it happened because a damaged extension cord sent live current right into the metal scaffold he was on. But this wasn't just one mistake. It was actually a chain of 3 huge failures all happening at once. You can see them right here. There was no GFCI protection, there was no equipment inspection, and that little ground prong was missing. Each one of these is a direct violation of the rules we're about to get into. Okay, so that story shows just one type of danger, but electricity on a worksite, wow, it presents a whole range of hazards, and a lot of them are totally invisible until it's way too late.
Now look at this. How many times have you seen a cord that looks just like this? It's frayed, it's damaged. It is so easy to just walk right past it and think, it's probably fine. But this right here, this is exactly where a deadly hazard can be hiding in plain sight.
The OSHA rules are basically designed to fight 4 main villains. First up, you've got electric shock, which can be anything from a painful little zap to a really severe injury. Then, you have its fatal counterpart, electrocution. There's also the risk of fire, which can happen when circuits get overloaded. And finally, something called an arc flash, which is this violent, explosive burst of energy that can cause just horrific burns. And this is no small thing. These incidents are so common and so deadly that they're actually part of what OSHA calls the Fatal 4, the top causes of death in the entire construction industry. And that is exactly why these rules are enforced so strictly. So the big question is, how do we fight these invisible killers? Well, this brings us to the very heart of the regulation, the main protective measures that every single job site has to use. OSHA basically gives employers 2 paths to take to protect workers from shock on all those 120-volt outlets. Option 1, use a device called a ground fault circuit interrupter, or GFCI. It instantly spots tiny leaks in the current. Or Option 2, they can set up a really strict system of inspections called an Assured Equipment Grounding Conductor Program, or AEGCP for short. I bet you've seen these GFCIs before. They can be built right into a wall outlet, the ones with the little test and reset buttons. Or they can be part of a portable extension cord, like this yellow one here. They might look different, but they all do the exact same life-saving job. And here's what's so incredible about them. A GFCI is always measuring the electricity going out and the electricity coming back. If it senses an imbalance as tiny as 4 to 6 milliamps, we're talking thousands of an amp, it just assumes that electricity is leaking out somewhere it shouldn't be, like through a person. And bam, it shuts the power off in a fraction of a second, faster than you can blink. Now, the other option, that AEGCP, it's not a device, it's a process, it's a discipline. It means the employer has to keep a written program, do daily visual checks on every cord and tool, and run formal electrical tests every 3 months. And they often use a color coding system to show that an item has been checked and it's safe to use. Okay, so GFCIs and inspection programs are absolutely critical, but they're only going to work if the basic wiring itself is safe. And that brings us to our next section, the fundamental rules for wiring and grounding. And there it is again, the ground prong. Let's talk about why this little thing was so important in that story we started with. The ground wire gives stray electricity a safe path to travel straight into the earth. If that prong is missing and there's a fault, that stray electricity is going to find another way out, like through a metal scaffold and then right through a worker. So the rules here are simple, but they are totally non-negotiable. Grounding has to be intact, always. All extension cords have to be the 3-wire type, which means they have that ground wire. All the wiring needs to be protected from getting crushed or cut. And the second a cord is damaged, it has to be pulled from service. Immediately. No excuses, no quick fixes with a bit of tape. And then for fire prevention, you have overcurrent protection. We're talking about your circuit breakers and fuses. Now, their job is different from a GFCI. They don't protect you from shock. They protect the building from burning down. They cut the power when a circuit is drawing way too much electricity, which could otherwise make the wires get super hot and start a fire. So we have the devices, we have the rules for wiring, but you know what? None of it means anything without the human element. Safety isn't just about equipment, it's about culture. It's about a shared responsibility. And this slide just breaks it down perfectly. The employer, they have to provide the safe gear, the GFCIs or the inspection program, and they have to train everybody on the hazards. But the employee has a huge role too. You've got to inspect your cord before every single use, test a GFCI before you plug into it, report damaged gear right away, and never, ever, ever bypass a safety device like a ground prong. It has to be a partnership. So we'll leave you with this question. Now that you know what to look for, what's one potential hazard you can spot in your own environment right now? Maybe it's a frayed phone charger, an overloaded power strip in the office. What about that missing ground prong on a cord in your garage? See, safety awareness doesn't just stop when you clock out. What you've learned here today can help keep you safe everywhere.